binomial coefficient for counting combination with repetition. This is very important. So previously we know that combination with no repetition, this is the figure. So this is 5 boxes, and then we do 5 choose 3. Okay, 5 choose 3. The answer is 5, 3. What's the figure here? The figure here is showing that I have 5 boxes. 5 boxes means what? The width here is 5. Okay, and then what? I want to select 3 boxes within these 5 boxes, and here the red boxes are the selection. Okay, the red boxes are the selection. And then, for example, if you look at here, this is 1, 3, and 4. And if you look at all the number here, they are all 1, 3, and 4 with just different permutation. Recall that combination, you don't care about order. Permutation, you care about order. So for permutation, these are different. But for combination, they are the same thing. So therefore, combination is like this. How many combinations I am? Calculate this number. It will be what? It will be 5 factorial divided by 5 minus 3 factorial and 3 factorial. Okay, something like that. Okay, so this is how you count if you are trying to choose k boxes from n boxes. What about if we allow repetition? If we allow repetition, the situation is very similar. First of all, you draw the same thing. So you have n boxes here, and you are going to select k boxes. Okay, you are going to select k boxes. Now here's the new thing. So you imagine for repetition, there's a what? There's a hidden new column. There's a new column here. Okay, there's a new column. What's the width of this new column? The width of this new column is k minus 1. Okay, k minus 1. So what the heck does it mean? Well, you are going to select k object, but you allow them to be repeated. And because there's a repetition, that means there is already one object you already know in the repetition. So you have to subtract 1. And you grow these boxes from n to k minus 1 means that you are treating those repetition as extra object you can select. So that means you now consider these bigger boxes. So what's the width? The width now is n plus k minus 1 plus k minus 1. And you are going to select k of them. So therefore, what you have will be n plus k minus 1, select k. So this is the binomial coefficient. And how do we do this? So here's an example. Suppose we have cats and dogs in a farm. So that means we have 2 things. Okay? And then how many ways can you select 3 pets to take home? So that means k is 3. Okay? In this particular example, we don't care about how many dogs or cats in the farm. We assume there are infinity many cats and infinity many dogs in the farm. Okay? And then let's solve it. So let's say f is a set 1, 2. 1 means cat, 2 means dog. So the question is same as how many ways can you put 3 boxes to fill in 1 and 2? And you just need 3 numbers. Each of the boxes is either 1 or 2. How many possible combinations are there? So there are 8 possible cases if we enumerate all the possible cases. So we have this. What's this? This is 1, 1, 1. That means cat, cat, cat. 1, 1, 2 means cat, cat, dog. And 2, 2, 2 means dog, 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 and so on. You have this. But we are now considering what? Combination. So first of all, you can see that there are repetition within the combination. So for example, 1, 1, 2, that means we have repeatedly selected 2 times the cat. Okay? If in the ordinary combination we don't allow repetition, then this is not allowed. But now we allow repetition, so this 1, 1, 2 appear. And it's the same for 1, 2, 1. But you know, for combination, 1, 1, 2 is the same as 1, 2, 1. How do you see that? Okay, so I recall you, ARB is the same as BRA if the operation is commutative. Okay, I talked about it in the previous slide. So you can think of it that 1, 2, 1 is actually what? 1 operation, 2 operation 1. There's a symbol here, and this symbol is what? Commutative. So I can swap these two. I can have 101, 102, and therefore, what's this? 112, which is this guy. Normally, we don't write a symbol here. We don't write a symbol. Okay, but this is an illustration. So 112 is the same as 121, and it's also the same as 211. So that means these 3 guys are the same thing. They are all 2 cat, 1 dog. Okay, so therefore we have to remove them. So if we remove those repeated version, you will see this is the result. We will have either 3 of them are cats, 3 of them are dogs. Okay, this is 1 dog, this is 1 cat. Okay, these are the all possible cases. There are 4 of them, and magically, if you use this formula, n is 2 because we have a set 2, k is 3, so we have 2 plus 3 minus 1 gives this, which is exactly 4. Okay, so here's the thing. If we choose k element from an n set with repetition is allowed, usually for the normal binomial coefficient, you may think that, okay, n will be larger than k. But when repetition is allowed, k can be larger than n. Okay, in this example, n is 2 and k is 3. Okay, k can be larger than n. Okay, and then, okay, so now let's talk about another example. The example below is a farm has bird, cat, and dog. How many ways can you select 3 pets? So now the set is 1, 2, 3, which is bird, cat, dog. Okay, so n is 3. Okay, and then here are all the brute force possibilities. So there are 27 cases. How do you get that? 3, 3. How do you see that? You have 3 animals to choose. So the first time when you look at this, you have 3 branches. Then you select either cat or bird or dog. And then for the second box, you have 3 branches. For the second box, you have 3 branches. For the second box, you have 3 branches. And then you have 3 branches again. So that's why you get the 27. This is the tree thinking, okay? But again, now we're talking about what? Repetition. So you see, 111, we have repeated chosen 1. Okay, 112, we have repeated chosen 1. So there are repetition here. For ordinary combination, we don't allow repetition, but now we allow, okay? And also, another thing, combination is unordered. So 133 is the same as 331 is the same as 313. So we remove all those same combination, we will get this. If you count them, this is 10. And if you don't want to do this approach by listing all the possible cases, that means by enumeration or brute force, you use this formula. The idea is same as you have 3 kind of animal, and then you want to choose 3, but you allow repetition. So that means 2 of the boxes, you have 2 more animal you are allowed to repeat, okay? So therefore you have 5 of them. 3 animal, but you have 2 more boxes. You are seeing it as 5 animal, choose 3. So here's another example. So suppose I have bird, cat, dog, ducks. So I now have 1, 2, 3, 4. So now n is 4. And again, I want to choose 3 animals. So these are all the permutation. There are 64 of them. So if we remove all the repeated one, we have 20 of them. This is the formula, okay? Another example. Suppose you have 5 types of battery, AA, C, D, and 9 volt. How many ways can you choose 20 battery? Again, here's a reminder. Usually, we think that, oh, K has to be smaller than N. But this is for the case if there's no repetition. But if we allow repetition, then K can be larger than N. In this case, K is 20. N is what? Just 5. So we use the formula here, 5 plus 20 minus 1, and then 20 below, we get this. Okay? And if you use calculator, it will give you this number. Okay? Another example. You have 5 soda, for example, Coca-Cola, Pepsi, 7-Up, okay? And then you buy 7 cans, and you ignore whatever you get. You just want 7 cans of soda from these 5 types. How many ways can you take? Then, by formula, N is 5, K is 7, so 5 plus 7 minus 1, and then number 7, and then you get this, you have 330. And again, what's the picture thinking? The picture thinking is you have 5 types of soda, and now you want to buy 7 cans. So 7 minus 1 means you have 6 repeated new boxes. So you add 6 boxes here. And totally, there are 11 boxes. And from these 11 boxes, you choose 7. So like this, okay? So this is the way, okay?